Good evening, millennials. Today, we'll look at another lead code medium problem often asked in FAANG interview companies such as Amazon and Google. I've seen this question appear in the last rounds. So let's read the question. This is the 777th question in the lead code website called swap adjacent in LR string. So the question goes as follows. In a string composed of L, R and X, characters like RXXL, RXRXL, a move consists of either replacing one of the occurrences of XL with LX or replacing one occurrence of RX with XR. Given the string start and the ending string end, return true if and only if there exists a sequence of move to transform one string to another. So it seems pretty straightforward, but let's look at the example to understand it better. So the start string is RXXLRXRXL and the end string is XRLXXRRLX. So we have to return true. This is because, let's look at the following steps. The initial string is RXXLRXRXL. I just swap this RX and put it as XR because this move is allowed. RX with XR and XL, let it be the same, and RXRXL, the remaining string, remains same. Then for the next move, I replace this XL with LX. So I replace the XL with LX and the remaining string remains same. For the next move, I replace this XR with RX. So you get XRRXL. Then at last you replace this XL with LX and you get the final string, which is our output, so it is true. And if you start with X and end with L, you can never be able to get it, so the output is false. So let's look at the constraints. So start.length is less than or equal to 10 power 4 and always start.length and end.length are same. So this is an important condition. Both start and end will only consist of these three characters L, R and X. So let's look at the hint. So you can think of L and R's as people on a horizontal line where X is a space. The people can't cross each other and so you can't go from XRX to RXX. So I'll just explain a base case. So assume you have a string, say some XXXL LRRXXL. So and you need to transform it to say something XXLXXRRXXL, say something. Assume both the lengths are same, 3, 6, 9. So if you see, when you remove the X from both the strings and compare, the L and R both strings should be same because the relative positions of L and R apart from X should be same because we are only swapping XL with LX and XR and RX with XR. So that is one condition. And in the second condition, you can see that L only goes to the left and R only goes to the right. So you can have two pointers going in traversing in each string and you can check whether the relative positions of L and R are same. So in that way you will be able to verify whether it's a valid string or not. So as I write the code, it will be more clear. So let me just declare two pointers p1 and let its position be 0 and let n be the start dot size. Remember that start dot size and end dot size are same. Then I need to check whether after removing all the XX, the X from both the start and end string, the remaining string should be same. So let me just declare two strings, S1 and S2. So let S1 be start and let S2 be end. So from S1 I just remove all the XX. So I just use the STL library, S1 dot erase of remove of S1 dot begin comma S1 dot end comma X. I just remove the X till the S1 dot end. Remember, this is easier in Java, but remove function just gives a call back to the erase function. So we have to write it like this one. So similarly for S2, just erase s2 dot end and then here also you remove the x, and then you check till the end. So at last, if s1 is not equal to s2, then you can directly return false, because the relative portions of L and R after removing the strings, after removing the x from both the strings, should be same. Now let me just do the two pointer method. While p1 is less than n and p2 is less than n. So remember, this s1 and s2 is just for computing, easy way to computing the strings without the letter x. So if start of p1 equal to x, now I need to compare the first positions of L and R. So till that I move the pointer p1 plus plus, because I don't care about an x. Else, if end of p2 equal to x, I just move p2 plus plus. So it should be else if. So either of these condition holds. Else, it means that neither of the position of the pointers is L and R. So here we can do an innovative check. So if start of p1 equal to L, so from the first condition we already know that the relative portions of L and R will be same, but right now we are checking whether it's possible to make an XL as LX. So we need to check whether in the final string the L should be towards the left side and not towards the right side. So since p1 is the pointer in the first string, when it's L, and if p1 in the first string, if the L position is lesser than the second position, or similarly it can be for R as well. So if start of p1 equal to R and p1 greater than p2, which means that in the first string the R is more towards the right, but in the second string R is more towards the left. In this case we just return false, because this case will make it not possible to get the final string. Remember, we have to do it in order of n using the two pointer method, because it's 10 power 4. And after all these cases, if it passes and comes till the end of the loop, so I don't think we need this bracket. Sorry, lead code is assuming the incorrect brackets, so I just close this if bracket, then return false. Else, for this else condition there's a whole bracket, then this while, then this is the end of the function. So after passing all these cases, we have checked all the negatives, and so it should return true. So let's run the code. Ideally I would go through it once. Okay, so let's just try to debug it. So int p1 equal to 0 and p2. Okay, so if okay, so here after this condition we are not moving the pointers p1 and p2. So if this is the case, we need to return false. Else we need to increase the pointers p1 plus plus and p2 plus plus. In that case we will traverse the whole string. So that's why it was giving a time limit exceeded, because it got stuck in the loop. So as you can see, in this case it works. So let me just run through the code. So here I'm just checking, I'm removing all the x's from both strings and checking. Else I have one pointer p1 here and p2 here, until it reaches the first L or R I'm just moving it. And once it reaches the L or R, if pointer 1 is in an L, and if the pointer 2 is greater than the pointer 1, which means that we have passed this L before itself, then it's not possible to get the solution. So we return false. Similarly, for R, if P1 is greater than P2, we return false. I've just submitted it a few minutes before to check for corner cases, and as you can see, it passes with a very good time. And this is the very short code you can find on LeetCode. If you have a better solution, please leave it down in the comments below, or feel free to suggest some better approaches than this. But this was the shortest code we can come up today. Thank you for watching our video. Please hit the like button and subscribe. Thank you.